Good morning everyone. My name is Mohit Kumar. I am a student of BSc IT first year, and first of all I thank to Anjesh sir for giving me this opportunity to present my presentation in front of you all. So today is my agenda is we know what is deadlock and condition for deadlock, and deadlock handling method and deadlock prevention method. In deadlock handling method we know about deadlock prevention method. So we know first what is deadlock. Deadlock is a situation where two or more processes are waiting for some event to happen, but there is no any event happen. Then those process is said to be involved in deadlock. Let's suppose we let's understand with example. Let two trains coming towards each other in a single track, and both of any one of them not reaching to their allotted station, means this situation is known involved in deadlock. As you see in this diagram, we have process P1 and P2, a resource R1 and R2. Process P1 is a request for resource R2, and resource R2 is assigned to process P1, and P1 process P2 process is waiting request for resource R1, and resource R1 is allotted to process P1. So in the next slide we know condition of deadlock. There are four condition for deadlock. First is mutual exclusion, second is hold and wait, and third is no preemption, and fourth is circular wait. In mutual exclusion, the resource has to be allotted to the process P1 and at a specific process P1, and as you see in this diagram, resource R1 is assigned to P1, and P1 is request for R2, and R2 is waiting for P2. So in hold and wait, the process is holding the resources and waiting for other resources. In no preemption, at least once the resource is allotted to the process, then it can't change according to, by priority. Here process resource is not changed according to priority. In circular wait, as you see in this diagram, process is circularly waiting for the resources. In the next slide, we know deadlock detection. We can detect deadlock by using two methods. First one is resource allocation graph, and second is Banker's algorithm. In resource allocation graph, it show the which resource is allotted to the which process, and which resource is waiting for which process. In Banker's algorithm, we detect deadlock by using a table. In table we have given allocation, available, and maximum need, and we have to find remaining need. If remaining need is less than equal to available allocation, then we can say process is in the safe state, and if remaining need is greater than allocation, then we can say process is unsafe state. If process is in safe state, then we can say here there is no deadlock. And in next slide we know deadlock handling method. There are four. This is the deadlock handling method. First is deadlock prevention method, and it is a very costly method. Deadlock avoidance method, deadlock recovery, and deadlock ignorance. In deadlock prevention method, if any one of them condition like mutual exclusion, hold and wait, no preemption, and circular wait, if any one of them is dissatisfied, then we can say process is not in deadlock. So in the next slide, so thank you everyone.